You know, Ray's absolutely right. There are a lot of technicians who don't know the importance of correctly adjusting wheel bearing end play. They're not aware that the results of an improper adjustment may be leaky seals or shortened bearing life, even when the adjustment may not seem to them to be much off the mark. In fact, a recent Rockwell survey showed that over half of the bearings on the road today are adjusted wrong. As a Rockwell service representative, it's my job to help you understand the importance of adjusting wheel bearings within the specified range and to offer you a procedure that will give you the best opportunity to hit the target range on your first attempt. I'd like to begin by taking you back to a visit I had with our friend Ray a couple of weeks ago. We were shocked at the results of the survey. Over half of the bearings were out of adjustment.
It's pretty scary, John. Yeah. But I have to tell you, I've seen a lot of guys I've worked with use some pretty screwy methods to adjust the bearings.
And every time somebody puts a truck on the road with a bad adjustment, the story has the same ending. The bearings die before their time. Yeah, that's why bad adjustments are such a costly problem for the trucking industry. Here, let me show you something. This graph tells the whole story. It shows how bearing adjustment affects the life of a wheel bearing set. Well, bearing life is shown on the left, and the adjustment specs are shown along the bottom. You can see that maximum bearing life can be achieved if the bearing is under a small amount of preload, or if just the right amount of end play is established. But if you have too much preload, you take miles off the bearing's life. Or if you have too much end play, you get the same result, reduced bearing life.
So the idea is to establish just the right amount of preload or just the right amount of end play?
Well, it would be, but the problem is it's extremely difficult to accurately measure preload on wheel bearings in most situations. However, you can measure end play by using a dial indicator. That's why Rockwell recommends establishing a certain amount of end play for our bearings. The procedure we recommend allows you to establish end play in the 1,000ths to 5,000ths range for non-drive front axles, and for drive axles and trailer axles, 1,000 to 10,000.
So the whole idea is if you shoot for the right amount of end play, you can verify it by using a dial indicator.
You got it. Simple, huh?
Yeah. You don't have to be a rocket scientist to handle that.
You see, what we're trying to do at Rockwell is get everybody that services our product to use this procedure. Or if they think they have one that works just as well, to at least check their final adjustment with a dial indicator to make sure end play's within the right range.
Now, the graph showed how the right adjustment has a lot to do with the life of the bearing. From what I've seen, though, a bad bearing adjustment wipes out a lot more than just the bearing. In a lot of cases.
Well, yeah, it sure does. Bearing adjustment does affect a lot more than just the bearing. Bearing adjustment affects the operation and service life of the spindle, wheel seal, brake components, and tires. And although a lot of technicians don't realize it, the bearing adjustment also affects tire wear because it influences front axle settings like toe-in.
A bad bearing adjustment can affect fuel economy, can't it?
Well, it sure can. And that's a subject close to every trucker's heart.
So when you say that bad wheel bearing adjustments are a costly problem for the trucking industry, you're talking about all the ways the adjustment can cause downtime and rack up repair expense.
Exactly. So have I convinced you to set wheel bearings to the specified end play range?
Yeah? You gonna show me how to do it?
Hey, I thought you'd never ask. I'll tell you what, you grab your torque wrench and a dial indicator, and I'll grab my shop coat and show you how to adjust bearings to meet those end play specs.
Okay.
Now, there are 5 steps involved in this procedure. The first step is to torque the adjusting nut to seat the bearing in the wheel seal. Now, always spin the wheel while you torque the adjusting nut. This makes sure that the bearing cage and the race and the seal are fully seated when you make your adjustment. On front axles, torque the adjusting nut to 100 foot-pounds. Then, back the nut off till it's loose. Now, here's where you actually establish end play. At this point, torque the nut to 20 foot-pounds. Then, back it off 1/3 of a turn, or 2 points on the nut. Install the jam nut. Then torque it to the proper specification, which varies depending on the size of the nut. Now, jam nuts less than 2 5/8, like this one, should be torqued to 200 to 300 foot-pounds. Nuts 2 5/8 and over should be torqued to 250 to 400 foot-pounds.
Now it's time for the dial indicator, right?
If you would, please. Now, what's the spec we're looking for here?
Let's see. Front non-drive axle, 1 to 5 thousandths.
Right. Let's see how we did. Yep, there it is. Let's check it one more time. Perfect.
Question.
Fire away.
What if you use this procedure and the dial indicator tells you that you're still out of spec? Is that possible?
Yeah, that can happen because of variations in the spindle and nut thread tolerances, differences in lubrication, even torque wrench calibration. If you have a situation like that, loosen the jam nut, then slightly turn the adjusting nut until you bring the end play reading within specification. And be sure to recheck the end play reading with your dial indicator. I'll tell you, while we're at it, let's check a rear axle bearing so you can see how the same procedure is used.
How about this axle?
Hold on a second. Let me show you a new procedure for removing axle shafts.
Hey, I like that.
Actually, this step is exactly the same. You spin the wheel and seat the bearing and seal by torquing the adjusting nut to 100 foot-pounds. Now loosen the nut, then torque the nut again. Now on rear axles, you need to torque the nut to 50 foot-pounds. Then back off the nut 1/3 turn. And install the jam nut. Again, the torque spec for the jam nut varies with the size of the nut. For nuts that are less than 2 5/8 inch, torque them to 200 to 300 foot-pounds. For nuts 2 5/8 inches and over, the spec is 250 to 400 foot-pounds. If a bending type lock washer is used like this one, the jam nut needs to be torqued to these specs. Less than 2 5/8, 100 to 150 foot-pounds. 2 5/8 inch and over, 100 to 200 foot-pounds. And we get a reading of 5 thousandths.
So we're right on the money.
By the way, I know I'm throwing a lot of specs at you, but I'll be giving you a copy of a printed spec chart Rockwell's developed to help you remember all the torque and end-play specs you'll need to adjust wheel bearings. Well, now how about you handling the trailer bearing check while I coach you along?
I don't know. You know how I hate to get dirty.
Right. Sorry, sometimes I forget. Okay. Now, the trailer bearing adjustment is a lot like the procedures I just showed you for the front and rear tractor axles. So you go ahead and see how much you remember, and I'll tell you when there's a change.
All right, here we go. First, I torque the bearing nut to 100 foot-pounds while spinning the wheel.
Right.
Back it off till it's loose. Now, I torque the adjusting nut to 50 foot-pounds.
Uh-huh.
And back the nut off a 3rd turn like the front and drive axle.
No. Now, here's where the specs change a little bit. Back it off only a 1/4 turn.
Okay. Install the jam nut. Now, how about the jam nut torque?
Well, now, these are a little different. I'll tell you what. Let's take a look at that chart I was telling you about. Now, here we go. Now, for jam nuts less than 2 5/8 inches, torque them to 200 to 300 foot-pounds. 2 5/8 and over, 250 to 300 foot-pounds.
Okay. This is a 3 1/4 inch nut, so I want to torque it to 250 to 300 foot-pounds. Yeah.
Now, what's your end play reading?
3,000s.
Perfect. The range for trailer axles is the same as the drive axle specs. Anywhere between 1,000 to 10,000 is okay.
I've got another question. How come the end play range for drive axle and trailer axles is 5/1000ths of an inch wider than the range for front axles?
Axle design considerations have typically led to larger capacity bearings being specified for drive axles and trailer axles as compared to front steer axles. And the larger bearings reduce the sensitivity to bearing end play adjustment.
Yeah, that makes sense.
Now, while we're talking about trailer axles, there's one more point you should be aware of. Rockwell International has an optional bearing package called Positive Adjust that's available on some models. Procedures for the Positive Adjust option are explained in Rockwell Technical Service Aid number TSA 5-12. So be sure to study this information before adjusting trailer axles equipped with this option. So the bottom line is that adjustment procedures are pretty much the same for front axles, rear axles, and trailer axles, but the specs vary in certain steps. So tell me, how does Rockwell's procedure compare with what you've done in the past?
Well, let's just say that I feel a little more confident that I'm doing things the proper way. Let me ask you something. When you find a bad wheel bearing, can you tell if a bad adjustment caused the problem?
Well, in many cases you can, on bearings and also on spindles and seals. Do you happen to have any damaged parts laying around?
Yeah, I do. I got some in this box I just took off recently.
Let's take a look at them. See all this wear on these rollers?
Uh-huh.
Well, this is what happens when there's too much preload. This wear is caused by the excessive thrust loads put on the bearing and also by the lubrication being squeezed away from the contact area. And I'd say this spindle could have also been trashed by bad bearing adjustment. You see here these signs of overheating?
Yep.
Well, they tell you that somebody put excessive preload on the bearing. The location of the heat marks indicate that the outer bearing failed before the inner bearing, which is usually the case. And this one was probably ruined by a bearing with too much end play. Your clues here are all these score marks on the bottom of the spindle due to movement of the bearing. Well, this seal was also the victim of a bad bearing adjustment. What do these signs of overheating tell you?
Too much preload.
Bingo. What do you think may have caused this eccentric wear pattern?
Too much end play?
Yep. Well, I hope we've helped you understand just how important wheel bearing adjustments really are. You can see why it's critical that you establish end play within the specified range every time you adjust a wheel bearing. You might have an adjustment procedure that you've been using, and you may feel confident that it establishes the right end play. If that's the case, do yourself a favor. Next time you adjust a bearing, check the end play with a dial indicator. If your procedure works, use it. If not, use the method we've explained in this program. The key point is that you check the adjustment with a dial indicator. Our job at Rockwell is to help you give your customers the best service their money can buy. So if you have any questions on bearing adjustment procedures, give us a call at this toll-free number. Thanks for joining us today.